Good day, children. Today for class 8, the topic is understanding quadrilaterals. Okay? Understanding quadrilaterals. Now, before we come to quadrilaterals, we'll see what are polygons and then come to quadrilaterals. Okay? Now, what is a plane surface? Example of a plane surface? Yes, we can say a sheet of paper is a plane surface. The top of your table or desk is a plane surface. This board is a plane surface. The wall is a plane surface. All these are plane surfaces. Now, on the plane surfaces, we can have figures. Okay? Supposing I have a figure like this. Okay, or like this. Yes. Now these are all simple curves. What are they called? Simple curves. Simple curves meaning when I start drawing it on the surface, I do not come across the same any of the same points that are there already when I finish drawing the curve. Just say like this. Supposing I have a curve like this. Now when I am drawing this curve, what happens is there is a point which is common. I have come across this point already like this. So this is not a simple curve. These are simple curves. These are simple curves, and if I retrace that point, then it becomes a not simple curve. Okay? So you have understood what is a simple curve and a not a simple curve. Now if the simple curve is closed like this, then it becomes a closed simple curve, a simple closed curve. Now this is an open curve and this is a closed curve. Okay? Now this is a closed curve, but it is not a simple curve. Do you understand? So simple curves are figures where when you draw on with the pencil, you do not make any common point when you finish drawing the curve. Understand? Now supposing I have like this. Okay, like this. Now this is a simple curve, as well as since it is closed, it is a simple closed curve. Have you understood? Now these curves, if they are made up of line segments only, this is a closed curve, it's a simple closed curve, right? Now if they are made up of line segments only, then it becomes a polygon. Okay? Right? See, supposing I have like this. Now it's a curve, closed curve, and it is made up of only line segments. So it is a polygon. Now supposing I have like this. This is also a closed curve and it is made up of only line segments. Then it is called a polygon. Okay. Now polygons can be classified by the number of sides that they have. When they have 3 sides, it is called a triangle. Okay? When there are 4 sides, it is called a quadrilateral. When there are 5 sides, it is called a pentagon. What is it called? Pentagon. When there are 6 sides, it is called hexagon. Correct. So let us write down the different simple polygons that we have come across. So when it is 3-sided, it is called a triangle. When it is 4-sided, it is called a quadrilateral. Then when it is 5-sided, it is called a pentagon. When it is six-sided, it is called a hexagon. When it is seven-sided, it is called a heptagon. When it is eight-sided, it is called a octagon. Gon means sided. Okay, oct means 8 and gun is sided, 8-sided figure. So when it is 9-sided, it is called nonagon. And when it is 10-sided, it is called a decagon. So have you understood how polygons are classified according to their sides, to the number of sides? Okay. What is a diagonal? Diagonal is a line joining two non-consecutive sides, corners of a polygon. Now supposing I take a four-sided figure. Now this is one corner, then this is the adjacent corner, this is another corner. So a diagonal is a line which joins two non-consecutive vertices. So this vertex and this is consecutive, so we will not use that. This will be a diagonal. Similarly, this will be a diagonal. Correct? So a diagonal is a line joining two non-consecutive vertices of a polygon. Now, based on this diagonal definition, we have convex polygons and concave polygons. Now, what is a convex polygon? Convex polygons means all the diagonals are interior. Interior means inside the figure. Now, supposing I take a four-sided figure like this. When I have two diagonals. Both the diagonals are inside the figure, inside, interior. This is the interior portion and this is the exterior portion, right? Exterior means outside the figure. So the diagonals are inside, so it becomes a convex polygon. Now, supposing I have a figure like this. Now what happens? These two will be a diagonal, these two will be a diagonal, this will be a diagonal, right? These two will be a diagonal. All the diagonals joining two non-consecutive vertices are interior. So it is also convex polygon. Now let us see, now how many diagonals will a triangle have, by the way? The triangle will not have any diagonals, that you must know. A triangle, as all the three vertices are consecutive, so it is not possible to have any diagonals. So diagonals will start coming in only from four-sided figures and five-sided, six-sided, etc. So that is the convex polygon. Now let us come to concave polygons. Now supposing I have a figure like this. Now what happens? Two non-consecutive vertices. So these two are consecutive, so I can join these two. Then these two are non-consecutive. So this also is a diagonal. Yes. Now what happens? This diagonal is inside the figure. So it is an interior diagonal. Now this diagonal is outside the figure. So it becomes an exterior diagonal. So when the diagonals are not fully interior, we call them concave. Okay? So this we can even have these star-shaped things, no? Figures. Here also what will happen, these two will be one diagonal, means these two also will be a diagonal. It will be outside the figure. So when it is outside the figure, when the diagonal is outside the figure, or when the diagonal lies in the exterior, it is called a concave polygon. So have you understood what are convex polygons and what are concave polygons? Okay, let us recap. What did we learn? We learned simple closed curves and not simple closed curves, and open simple curves and not open, not simple open curves. Okay, so these are all figures that we learned earlier. Now let's, when the closed curves consists of only line segments, we have polygons. Yes, and polygons, based on the number of polygons, we classified the polygons. Yes, now we are classifying polygons by the diagonals. What's the diagonal? The diagonal is a line joining two non-consecutive vertices. Understand? So when we have that kind of thing, when the diagonal is interior, when all the diagonals are interior, it is a convex polygon. When even if one diagonal is exterior, it becomes a concave polygon. Have you understood? So what is a convex polygon and concave polygon? Then there is another type of polygon, that is regular polygon and irregular polygon. Regular polygon and irregular polygon. Okay. Now, when is a polygon called regular? When it is equiangular and equilateral. That means all sides are equal. Equilateral means all sides are equal. Equiangular means all angles are equal. So examples of a regular polygon will be an equilateral triangle. Equilateral triangle, all sides will be equal as well as all angles will be 60 degrees. Correct? Now, another thing is a square. Square is what? All sides are equal and all angles are 90 degrees. Correct? Then we have regular pentagons, regular hexagons, where all sides will be equal and all angles are also equal. Now you take, for example, a rectangle. What happens? All angles are equal, so it is called equiangular. But are all sides equal? No. So it becomes an irregular polygon. Have you understood? So regular polygons are equiangular and equilateral, and irregular polygons have to are polygons which do not satisfy either of these two conditions. Have you understood? Now I will give you some homework. Try and classify the curves and polygons as you have been asked to do. Thank you. Have a nice day.